All right, so now we are going to start working with our calculators. Yay! So we're going to find actual lengths of sides using our calculators and our trig ratios. And so this is going to be fun. So to find the missing side of a triangle with trig ratios, we need to identify a few things. One, based off of the angle we're given, so we are provided angle measure 15 for angle M. Based off of that angle, what does the side X represent? Is it opposite? Is it adjacent? Is it hypotenuse? Well, based on its location, it is the opposite side. So that means this is O, 12 is our hypotenuse, and MN is A. 12, as I just said, represents the hypotenuse. And so we have opposite and hypotenuse. Those are the two things we're going to be using. So what trig function uses opposite and hypotenuse? Well, let's look and see. Opposite O over H. We're going to use sine. So we're going to be using sine. So to find X, we're going to set up a little equation. We are going to say the sine, and we're going to input the angle measure, 15, is equal to the ratio of opposite, which is X, over the hypotenuse, which is 12. So remember, sine of theta, whatever angle we're using, is equal to the opposite over the hypotenuse. So in order to type this into the calculator, we need to make this one expression with X on one side, what we're trying to solve, and everything else on the other side. Just like if you were doing like 5 plus 2 plus X equals 12, I can't type it into the calculator like that. I need X on one side and all of the numbers on the other side. So in order to do that, I need to move that 12. That 12 is stuck underneath X. It's being divided with X. So in order to move that, I need to do the opposite, which is multiply. So I'm going to multiply both sides by 12 and cancel out the 12 on the right-hand side. So I'm left with 12 times sine of 15 equals X. Now, in order to type this in the calculator, I'm just going to type in everything on the left-hand side. So on your calculator, type in 12, and then you just hit the multiplication key, and then you'll hit sine, which says S-I-N, should be like 2 rows above 7, and then 15, close parentheses, and then you'll hit enter to solve. Again, double check that you're in degree mode. So what I get back is X equals 3.1058285541. Wow, big number. I'm not going to ask you to always give me a full number. Typically, we're going to ask for things to be rounded to the nearest tenth. So if I round to the nearest tenth, this is approximately. That little wavy equal sign means approximately, so it's not quite equal to, but it's our rounding equal to 3.1. So typically, you are going to be rounding. All right, so let's try another one. I have triangle ABC. I have the angle that's provided to me is 70. So from where 70 is, we want to identify our different pieces. It says find each of the following using the given triangle, round to the nearest tenth. Yes. So first, it asks me to find the measure of angle C. This is a triangle, so the sum is 180. I do have a right angle, which is 90. And so I have 90 left. So 90 minus 70 gives us 20. So angle C has a measure of 20 degrees. I'm given BC, and I'm told to find AB and AC. So based off of angle 70, you can use 20 as well. I'm going to go with the one that was already provided for me, but you can use angle of 20 as well. So from 70, 7.2 is my opposite, AB over here is my adjacent, and AC is my hypotenuse. So for AB, if I'm going to find AB, I'm given the opposite, and I'm trying to find the adjacent. So that's O over A, which is tan. So we're going to set it up using tan. So same thought of tan of 70 equals opposite, which is 7.2, over the adjacent, which I'm trying to find. You can use X, Y. If you want to use a different letter, that's fine. Now, my A is stuck in the bottom, so I have to get that out of the bottom, but I also need it on one side by itself. So this is going to take us through a few steps. I'm going to have to multiply both sides by A, which cancels out the A on this side. So then I'm left with A times tangent of 70 equals 7.2. But now I need to get rid of the tangent next to the A. I want it to be on the other side. So I'm going to actually divide by tan 70 on both sides. That cancels out. So I'm left with A equals tangent 7.2 over tangent of 70. And we're just going to put this in the calculator. I highly suggest using parentheses as an extra precaution whenever possible. So making sure you're keeping the 70 with the tangent, close that parentheses. But we're going to type this in the calculator, 7.2 divided by tangent 70. And that's going to turn us to 2.62058, yada, yada, yada. But we're going to round to the nearest tenth, so AB is going to be equal to 2.6. All right, we're going to do the same thing for AC. So AC is my hypotenuse. So since I have both the adjacent and the opposite, I can use either to find the hypotenuse, but I always like to go with the information that was originally provided, that's the smaller decimal, so the 7.2, the opposite side. If you were going to use the adjacent, what we just found, AB, you would need to take the whole decimal that was in your calculator with you. So it's a little easier just to take 7.2. So if I'm using the opposite and the hypotenuse, that means I'm going to be doing sine. So I'm going to set this up as sine of 70 equals the opposite, which is 7.2 over the hypotenuse, which I'm trying to find. Now, if you look back at our previous problem to find AB, we had A stuck in the bottom, and we had to multiply both sides by A, and then we had to divide by tangent to move it back to the other side. So if you look, the location of where tangent and A were just got switched. So all I have to do is switch H and the sine 70. So that's all I need to do. So H is equal to 7.2 over sine 70. And type that into the calculator. 7.2 divided by sine 70. And that's going to give me the hypotenuse is equal to 7.66207, yada, yada, yada. But again, we are going to round to the nearest tenth, as was our direction. So 7.7.